Hello and welcome. In this video, we will evaluate this expression using a table. And those of you following along as one of my students in my Canvas course have a very expensive textbook option, or you can opt into the optional one that is not officially the book of the course, but is optional. It's free. And that one is the OpenStax book. In the OpenStax book, there is something in the table of integrals that looks a lot like this integral right here, and it's number 89. But we need to do some algebraic manipulation before we can get it to look like this. So this is a great example to show kind of how to make integrals look like they would in a table. It's also a good example because there's a typo in the OpenStax book, and I'm going to write this out with the typo first, and then I'll fix it. Okay, so if you're looking here, you see this u over u. Well, that would just be 1. And this is the typo. So if you have a PDF copy of this book that you're using to follow along in my course, make sure you go in there, somehow mark it, make a note to yourself with a PDF editor, maybe print out that page and cross that out and put in a 2 here. And I'll leave that 2 in blue just to make it really clear that that's where the typo is. That said, let's begin rewriting and evaluating this integral. So this is x squared times the square root of 4 squared minus 3x squared dx. So this is getting closer and closer to what we want it to look like. Notice here this is just u, a variable. There's no constant in the front. So let's go ahead and apply a substitution. So let w equal 3x, then dw equals 3dx, which we can write as 1/3 dw is equal to dx. Now let's apply that substitution. So in our denominator here, we have the square root of 4 squared is still there, minus w squared. And then of course we have our 1/3 dw in place of this dx. But what about this x squared here in the numerator? How should I replace that, given that I have w equals 3x? So let's go ahead and rewrite this. That is, w is equal to 3x, so w over 3 is equal to x. If I want x squared, then that's just w over 3 squared. And that'll go here in my numerator. All right, so this is 1/3 times 1 over 3 squared from this right here times the integral of w squared over the square root of 4 squared minus w squared dw. Now we can actually apply what we see here from this table of integrals. So in our case, our u is actually a w, and our a is equal to 4. As you can see, this is our a right here. Okay, so this is 1 over 3 cubed times negative w over 2. And here I have the square root of 4 squared minus w squared plus 4 squared over 2 times arcsine of w over 4 plus our constant c. Finally, let's go ahead and clean this up. So every w we will replace with a 3x. I'll work out all these powers and simplify as well. And then we can take one more step to distribute this 1 over 27. All right, and then the final thing left to do is distribute that 1 over 27. And this will leave us with negative x. And then this 3 will get rid of one of these 3's here. So we'll have 3 squared, which is 9 times 2, so 18, times the root of 16 minus 9x squared, plus 8 over 27 times arcsine of 3x over 4, plus our constant c. I hope you found this video helpful.